Awang Ahmad Fitri Azizi bin Jasmine, Jeking Colin Santai, Nur Anisa Naziha binti Osman, Tazwani Akila binti Saibu. Introduction. Chemical infrared spectroscopy emerged as a science in the 1880s. In the 1890s, A. Michelson, to further his studies of the speed of light, invented the interferometer. In 1949, Peter Filget used an interferometer to measure light from celestial bodies and produced the first FTIR. But for many years, only a few advanced research groups with access to large, expensive computers and with personnel able to wait up to 12 hours to transform interferogram with a spectrum used FTIR spectroscopy. For 2 decades more, FTIR spectrometers were limited to studying problems not solvable with dispersed techniques. In the late 1960s, microcomputers able to do the Fourier transform, commercial FTIR spectrometers appeared.
Application and research. Infrared spectroscopy is widely used in both research and industry as a simple and reliable technique and for measurement, quality control, and dynamic measurement. The instruments are now small and can be transported even for use in field trials. With increasing technology in computer filtering and manipulation of the results, sample in solution can be now measured accurately. Water produces a broad absorbance across the range of the interest, and this renders the spectra unreadable without this computer treatment. Some machines will also automatically tell you that substance is being measured from a store of thousands of reference spectra held in storage. The measuring at specific frequency over time, changes in the character or quantity of a particular bond can be measured. This is especially useful in measuring the degree of polymerization in polymer manufacture. Modern research machines can take infrared measurement across the whole range of interest as frequently as 32 times a second. This can be done whilst simultaneously measurements are made using other techniques. This makes the observation of chemical reaction and processes quicker and more accurate. Techniques have been developed to assess the quality of tea leaves using infrared spectroscopy. This will mean that highly trained experts can be used more sparingly at a significant cost saving. Infrared spectroscopy has been highly useful for the application in both organic and inorganic chemistry. Infrared spectroscopy has also been successfully utilized in field of semiconductor microelectronics. For example, infrared spectroscopy can be applied to semiconductors like silicon, gallium arsenide, gallium nitride, zinc selenide, and silicon nitride.
Advantage. First, it does not separate energy into individual frequency for measurements. Second, it does not limit the amount of light reaching the detector using a slit. Third, it uses a laser to control the velocity of the moving mirror and to time the collection of data points throughout the mirror stroke. First explanation. Each point in the interferograms contains information from each wavelength of light being measured. Every stroke of the moving mirror equals one scan of the entire infrared spectrum, and individual scans can be combined to allow signal averaging. Second explanation. This means more energy reaches the sample and hence the detector in an FTIR spectrometer than in a dispersive spectrometer. The higher signal leads to an improved signal-to-noise ratio of the FTIR. The sensitivity of the instrument for small absorptions will be greater and details in sample spectrum will be clearer. Third explanation. This laser uses a reference signal within the instrument. The interferograms of the laser is a constant sine wave which provide the reference for both precision and accuracy.
These are the disadvantages of FTIR.
The first disadvantage is do not measure spectra but measure interferograms. Interferograms are difficult to interpret without first performing Fourier transform to produce spectrum. It is used to be a measurement problem, but since the dramatic increase in computer power, performing a Fourier transform is now quick and easy process. It also can affect the result, so must handle it with care. Next is the systems are source noise limited. It arises because all regions of the spectrum are observed simultaneously. Therefore, if noise occurs in one part of the radiation from the infrared source, it will spread throughout the spectrum in an FTIR system. And lastly, these instruments have only a single beam. For highly sensitive work and experiments which take a long time, changes in infrared absorbing gas concentration can severely affect the result. Therefore, it uses an infrared transparent gas such as nitrogen.
Conclusion. In conclusion, FTIR is one of the measurement techniques for collecting infrared spectra. It used in both research and industry for measurement, quality control, and dynamic measurement. It also been successfully utilized in the field of semiconductor microelectronics like silicon, gallium arsenide, gallium nitride, zinc selenide, amorphous silicon, and silicon nitride. Even though it has weaknesses, it also has advantages that give the benefit to the user.